In Learning Objective E, I'm going to show you how to calculate and interpret our third measure of spread called standard deviation. If you take a look at this dot plot over here that was created, it's the number of pets that various people said they had. I'm going to tell you that the mean number of pets, or the average for this case, was 5. So what we're going to do is look at the deviations of the various answers. So for example, whoever answered 7 pets, you're going to notice this line here is they have 2 deviations from the actual mean. The person here that said they had 1 pet, they are actually, this is the complete deviation that they are from the mean, so they deviate by -4. And it's negative because they are below the mean. So by definition, what a standard deviation is on average how far observations are from their mean. Now your calculator can actually do this calculation under the one variable stat, but I'm going to show you the formula and how it works. Their true definition is this: standard deviation, which is on your calculator S of x. By the way, S of x means for the sample. It measures the average distance the observations are from the mean. It's calculated by finding an average of the squared distances and then taking the square root. This average squared distance is called the variance. So the 2 vocab words we do focus on are variance and standard deviation quite a bit in this chapter. So here's what variance is, because we need to do that before we do standard deviation. The symbol is S of x squared, so it's a standard deviation squared. And what they do is they take each deviation, so my piece of data, or how many pets I have, minus the mean, and I'm going to square it. I do it again for the next piece of data, and I square it. And we do it for all pieces of data. Now, the reason we square that in particular is because if we look up here for the pets, we had one person deviate -4 down and +2 up. We want to eliminate that direction, because when you add all these values up as you do to compute the mean, if we were to add these two, in the long run they could cancel each other out and net out to 0, which would not make sense. So we square it to eliminate the negatives being subtracted. Well, you add all of those up, and for the sample what you're going to do is you're going to divide by the sample size -1. Now the shorthand notation for this can be written in sigma notation. It looks like this. It says here we're going to sum, that's what sigma stands for, every piece of data minus the mean squared, and you add them up. Once you've added them up, you're going to multiply or divide by the sample size -1. Now variance we need to compute before standard deviation, but it technically doesn't make sense. So for example, if you were to take this person with 1 pet, if we said the deviation here we already know is -4, but if we square it, it would be 16 squared pets. So squared pets makes absolutely no sense. So what we have to actually do is come in and take the square root of variance, which gives us ultimately the standard deviation, and it gets rid of the squaring of that label. So we don't have pets squared, we just have pets. This is a very common measure of spread that gets used in our book, and we're going to use it quite a bit in the latter half. Now the formula sheets that I gave you at the beginning of the year were the laminated ones. I let you use them on the test because they are the formulas they supply on the AP formula sheet. Do know this formula right here is supplied to you. This is the formula again for the sample's standard deviation. We will be looking at the population standard deviation, but later on in the book. Now, what are some of the properties of standard deviation that are important? Well, the first one is this. S of x measures the spread about the mean, and it's only used when the mean is chosen as the measure of center. So if you're describing a distribution and you choose median, you wouldn't talk about the standard deviation because standard deviation is very much so attached to mean calculations. Second one, S of x is always greater than or equal to 0. Now it can equal 0, but the only time it equals 0 is when there's absolutely no variability in the data whatsoever. This happens only when the observations all have the same value. So if you have a data set where all the data isn't the same, you will find a standard deviation is going to be greater than 0. Now, as the observations become more spread out, they're going to deviate more from the mean. So as that happens, what you're going to find out is the standard deviation will get larger. And hopefully that just logically makes sense. The third point here is as the standard deviation has the same units of measure as the original observations. And we talked about that before with comparing variance and standard deviation. Remember back in the pets, S of x squared is variance. Here we squared the pets and had a label of pets squared. So we had to come in and take the square root to get rid of that, so we just have the label of pets on that one. So it is the same unit of measure as our observations. And then the last one, like the mean, S of x is non-resistant. A few outliers in that data set can make the standard deviation very large and not a good representation of your measure of spread. Now, it's important you understand how the standard deviation is truly calculated, so we're going to look at just this very small set. We have 5 students who were asked how many minutes they spend doing the previous night's homework. The responses are here in minutes. So they want us to calculate and interpret the standard deviation. So what I first did is we could actually put this in our calculator, or we can just add these all up and divide by 5. When you do that, the mean number of minutes is 41. And in this case is our sample size, which is 5. Now, what we need to do is take each piece of data, all 5 of these, and first calculate the deviations. So they're going to look like this. The 0 minus the 41, the 25 minus the 41, and so forth. When you get a number for these calculations, we're then going to square it. Those will look like this. So what you're going to see here is this is going to be negative 41 squared is our 1,681. For example, 90 minus 41 is 49, and we're going to square that and get the 2,401. So this column here are the squared deviations. Now, this is what we just did, is we took the piece of data minus the mean and squared it. Now we need to sum them up. So if we sum them up, we're going to get 4,820. So we just got this calculation right here. Now let's continue on with the calculation. Let's take that sum value and then divide it by n minus 1. So here's the sum of the squared deviations. N is 5 minus 1. If we do that, we're going to get 1,205. So 1,205 is everything under the square root symbol. This is actually the variance. And if we put a label to it, keep in mind we're talking minutes, so the correct label for this would be minutes squared. Now, we need to come in and take the square root of that value to get our standard deviation, which is right here, taking the square root. And the new label this is going to be is for minutes. And that's how you would calculate the sample's standard deviation. Now, the last thing they want us to do is to interpret this. And this is going to be a really common question. So a good way to talk about how to interpret it would be to say something like this. Is that on average, the students deviate by 34.7 minutes in their study time per night from the mean. This is not the only way you can say it, but this is a general concept behind it.